Hi, let's look at stereochemistry, chirality, asymmetric carbon, CIP rules. Fisher projections, we'll look at it in the next video. Now, stereochemistry, the structure, the three-dimensional structure is important to understand the functionality of a molecule. It's especially important in drugs, molecules, and so on. Now, achiral, or sometimes we call achiral. So achiral means there is symmetry in the molecule or even a structure you're looking at. It could be some objects too. They could be achiral. Now in this carbon, there is two methyl groups, one hydrogen coming out of the page, one hydrogen going into the page. The methyls are on the screen. Now this is sp3 hybridization. Bond angles are 109, identical, and this is a tetrahedral molecule. Now, what's the specific thing this molecule has? It has a symmetry. You can cut through the two methyls. You can cut through the two hydrogens, right? Let's compare this one with the chiral compound. Now, chirals have asymmetry. That means they don't have a symmetry. It's an asymmetric carbon or asymmetric center. What's the asymmetry? Let's look at it. So this carbon has a methyl group, and this cannot be a methyl, right? Let's put something else, right? Let's say bromine. And then you have, here you have the, let's say chlorine, and then hydrogen we're going to leave. We need a hydrogen to show you something else. Now, so these are the four different groups, and it's sp3 hybridized carbon, and the bond angles are 109. It's tetrahedral, and these four different groups, sometimes we call tetris, so four different groups, it's important. When you have that one, this carbon center is asymmetric carbon. It's called the asymmetric center, asymmetric carbon, right? So that's the importance of achiral versus chiral. Now you can think about your socks. These objects are all letter A, letter B. They have a symmetry. Think about it. Now your shoes have no symmetry because these shoes are different, left shoes versus right shoes, right? And letter Q, letter R are chiral too. They don't have a symmetry. They are asymmetric. Your shoes are asymmetric. That's why you can't change your left shoe with your right shoe. It's also, you can think chiral means handedness. Okay, there's a left hand and the right hand kind of thing. Okay, now let's look at, if you have a mirror by this chiral molecule, asymmetric carbon, and you can mirror the picture to the other side. So hydrogen is closest to the mirror, and chlorine down closer to the mirror, and this methyl is like sticking up straight forward, and then this Br is away from the mirror. So that's how I mirror it, right? You can actually mirror it using your phone, any small mirror. You can see object and image. Now, so these are the object and image, and these pair are also called the enantiomer pair. So enantiomer pair means object and image of a asymmetric carbon-based molecule, right? So we can find out how we learn about them and study them. Empirically, we're going to use CIP rules. That's also called the Kahn-Ingold-Prelog rules. I'll put it in very simple form. So what you do first, you rank with the atomic number for each group. Consider the atomic number. But if you have the same atomic number, let's say hydrogen and deuterium, then you take the mass of it, atomic mass. In this case, bromine has a higher number, chlorine next atomic number, carbon next, hydrogen is the last. So the hydrogen last, we can leave behind actually, right? Now hold the last chiral priority away from you. That in this case, hydrogen is actually in the background because of the dashed line. So now take the rotation on the priority order, starting 1, should be 1 to the 2. So let's say 1 goes to the 2, and the 2 goes to the 3, and 3 can go back to 1, right? So that's the rotation. It's a clockwise rotation. And the hydrogen we are holding away from the viewer because we are looking at the screen, right? So now the rotation is clockwise, and we call the CW clockwise. So it's given R, that means rechts, R for rechts, right? Now, the other side of the mirror, the object in this case should be S. If it is S, it should be counterclockwise, right? Let's see whether it is true. Because we build the clockwise, the R. Now, priority again, bromine gets 1, chlorine gets 2, carbon gets 3, and get the rotation 1, 2, 3 because it's anti-clockwise or counterclockwise. The hydrogen we are still holding behind the screen. So therefore, that's why it's S. So now you learned about how to draw the mirror images, how to do the S and R on that structure, right? Now there's another thing you can learn quickly. What's that one? Use of a polarimeter to check the optical activity. Now the optical activity is measured by this optics device, polarimeter. And what you have a light source here, sodium lamp, and then you have a polarizer, and it gives you plain polarized light, and then it pass through the sample. And you look at from the very end, which is the detector basically, and you're going to see some dark area and the lighted area. So that's the angle you can read actually. So in this case, I put 12 degrees positive, right? Let's say this S compound pure, and then that shows 14 plus degree, let's say. Now this R compound should show you minus 14 degree. So that's the relationship. So one object shows, let's say, 14 degrees positive, and then its image should show you minus 14 degrees. So that's how you measure the optical activity, and this is an experiment only, and it's no relationship to the RNS though. These are two different things. Now, if you have a 1-to-1 mixture of S and R, so that's called the racemic mixture. Now, what's the racemic mixture do? So see, the 14 plus and 14 minus cancels out. That's a zero optical rotation. So that's what actually happens. So if I have 50% mixture or 1-to-1 mixture of the S and R molecules, and that will cancel out the optical rotation. So it makes sense, right? That means 50% turns left, 50% turns right, and it cancels out. Now, if you're interested, if you're in the healthcare degree programs, make sure you read about thalidomide. Any dentistry, medical, any field, you should know about this one. Thank you.